Welcome to the video on how to write your lab report for Experiment 4, Introduction to Separation Techniques Part 1. The objectives of the lab are to learn how different substances can be separated using two filtration techniques for heterogeneous mixtures. Solvent extraction separates a substance by using the property of solubility. Let's review some of the key terms and concepts. Solubility is a physical property measuring the amount that one substance can dissolve in another. This can also be done as a qualitative observation. For example, a teaspoon of salt will dissolve in warm water. When two liquids are mixed, they can be soluble, and the mixture is described as miscible. If the two liquids separate into two layers after mixing, the mixture is described as immiscible. A solution is a homogeneous mixture of two or more substances. A heterogeneous mixture has substances in two or more states. Filtration is a method to separate a heterogeneous mixture. In this lab, a filter paper acts as a physical barrier to collect the solid, while the liquid can be pulled through at different rates using gravity or suction. The solvent extraction technique uses a piece of glassware known as the septory funnel. When immiscible liquids are poured in, two layers can be observed. In the diagram to the right, a blue-colored substance is more soluble in the top layer, as seen by the darker color. The solvent on top has the smaller density of the two immiscible liquids. The denser solvent can be separated by using the stopcock to let the solvent drain out. In Part A of the lab, a demonstration of extracting iodine from water was shown. Observations could be recorded when the crushed iodine was added to separate beakers of ethanol, water, and paint thinner. Your observations can include the following: color and intensity of the solution, whether the solution is clear or opaque, if the iodine and solvent form a solution or a mixture. When iodine is soluble in a solvent, an orange or purple color is observed. From the lab demonstration, a more intense color indicates a larger solubility of iodine in the solvent. This is shown in the mixture of iodine and paint thinner. The iodine is least soluble in water at room temperature. After mixing, all the mixtures show an increase in color intensity, indicating that more iodine has dissolved in each respective solvent. The solubility of iodine in water is much lower compared to the other solvents. The iodine-water mixture is divided into two septory funnels without any solid iodine. Paint thinner was added to one septory funnel while ethanol was added to the second funnel. This is done to see if a solvent extraction can be achieved with paint thinner or ethanol. Your observations can include the following: color and intensity of the solution, whether the solution is clear or opaque. If one layer forms, then the solvent and iodine-water mixture is miscible. If two layers form, then the solvent and iodine-water mixture is immiscible. To check if an extraction can occur, each septory funnel was shaken so the dissolved iodine can make intermolecular contact with the added solvent. The mixtures were allowed to settle, and then more observations were recorded. In the septory funnel on the left, ethanol and the iodine-water mixture form a single layer, which means that the mixture is miscible. Having the same color in the funnel means the iodine is soluble in the whole solution. In the septory funnel on the right, paint thinner and water are immiscible. The dark color is observed in the top layer of paint thinner, and water appears to be colorless. This shows the solvent extraction has occurred because the iodine has a larger solubility in paint thinner than water. In a lab, you would also do more than one extraction with fresh solvent to ensure you have removed all the iodine present. Part B of the lab had a demonstration of a precipitation reaction. The separation of the solution and precipitate was done by vacuum filtration. Observations were recorded for both the solid sodium sulfate and barium chloride and their respective solutions. Review the key words shown for the qualitative observations of each solid or solution. The clear and colorless solutions of sodium sulfate and barium chloride were mixed together and a white precipitate was formed. This is known as the precipitation reaction, and the white solid in the mixture is barium sulfate. Although the liquid in the mixture is colorless, the solution has soluble ions of sodium and chloride in it. The apparatus for vacuum filtration was set up according to the picture. Vacuum filtration is advantageous when you need to filter a large volume of solution. Running water creates a vacuum in the filtration flask and pulls the solution down at a fast rate. A filter paper in a Buchner funnel traps the solid barium sulfate. For Part C of the lab, the apparatus was set up to practice gravity filtration. A piece of filter paper was folded to fit into a funnel to trap the sand, but the filter paper is permeable to water. The water is separated at a slower rate than vacuum filtration. To separate the mixture, the techniques for decantation, washing, and transfer of sand were done. Now let's go over the lab questions for the lab report. Please look over your marked labs for any mistakes you can correct. You can review your observations and the photos presented in this video for the questions. Question 1 highlights the key terms covered. You need to know their correct meaning and spelling for writing lab reports and future exams. Questions 2 to 5 deal with the demonstration of the extracting solvent. Use your lab observations in this video to help you answer these questions. If you need help, talk to your classmates, peer tutors, or the instructor. Before you write the conclusion, check your marked labs for ideas as well. Review the Lab 4 introduction. Many of the points to include in the conclusion have been covered in this video. When you begin to write the conclusion, please address the following points. What were the types of separation demonstrated in the lab? How does gravity filtration work, and what substances were being separated? How does vacuum filtration work, and what substances were being separated? What are the principles of liquid-liquid extraction? How effective is paint thinner used as the extracting solvent for the different mixtures? Thank you for watching this video on how to write your lab report for Lab 4, Physical Separation Part 1.